If you are a Chrome extension developer and you are using WebSocket or server-side event SSE for your Chrome extension, you might want to consider using Push API or specifically silent push in your application. If you're not a Chrome extension developer, this video might be useful for you in the future. Let's take a look what happened in Chrome version 1.1. From Chrome version 1.1, you can now send silent, non-user facing push notifications to your users. This is specifically for Chrome extension. This means you can send data using Push API silently from your server to your client without showing any notification. And this can be done using Push Manager and set user visible only to false. Now let's visualize how Push API work. First, you have your server, your web server, and then you have devices that run different browsers, and you have push server, where this push server is being handled by our respective browser vendors, Google, Mozilla, Microsoft. And first, your server will send API requests to the push server and ask them to send push to a very specific device. For example, your server send requests to Google, and Google will send requests to a Chrome browser in this PC. It's the same with other browsers like Mozilla, Firefox, like Microsoft Edge. And if you notice in this diagram, the connection is being retained by the push server but not your server. And the communication is unidirectional. It is a one direction. It is pushing from push server to your clients. But this push technology is not limited to browser. We also have Apple and Amazon, where Apple, they handle push notification for Apple devices. Amazon handle push notification for their devices. And as for Google, it's not only handle Google Chrome, it also handle Android devices that has Google Play in it. It's the same with Microsoft, where they handle notification for Windows and also they handle notification for Microsoft Edge. Historically, push technology is being used for push notification, but as I mentioned earlier, for Chrome extension, you can now send push data without showing notification. So let's take a look at a different approach on how we can send real-time data to our client. Now we have server-side event SSE, where we have our server, web server, and we have devices, and we establish connections directly from our server to our client without any push server because we handle everything ourselves. This means we need to retain all connections that we have between our server and our clients. And this approach is very good for you to send notification to your client, but it does not work in the background. And for services like Cloud Run, where you need to pay for CPU usage, this approach is not the best approach for you because you need to retain the connections. And if you are using Cloud Run or any other serverless services, that means you need to pay the full price. It defeats the purpose of serverless technology. Now let's take a look at a different approach of real-time communication. For WebSocket, we have server, web server or WebSocket server, and we have clients. And then we establish connection from our server to our client. But this time, take a look at the arrow. It's a bi-directional communication, which means from our server, we can send data to our client. From our client, we can send data to our server. So it's the same with server-side event where you need to retain the connection. But this time with WebSocket, it is much more expensive because it is a full duplex connection, which means it is bi-directional. We need to retain the connection from the server to the client and from the client to the server. This also means you need more resources for CPU and for RAM compared to server-side event. And also WebSocket uses a custom protocol for the connection. When WebSocket want to establish connection, it uses HTTP, but once the connection established, it uses custom protocol. So yeah, this is the diagram before for push server. And as you can see, the connection is not established by us. It's not retained by us. We just send data to push server if we have data. And the push server will handle everything for us. So why push API? Well, first, you don't have to retain connection. Second, it works in the background. This is something that you can achieve by yourself. In order for you to send something in the background, you need push API, you need push technology. And since this video actually I create for Chrome extension developer, you can combine push API with off-screen API, where the purpose of off-screen API is to create and manage off-screen documents, which means you can use document object model, DOM, together with push API. One example that I have here is the recent Chrome extension that I developed. I called it SyncBot, where it is a clipboard manager that synchronizes your clipboard. Every time you copy something from computer A, it will send push data to all connected devices, and then it will automatically copy that data into the operating system's clipboard. So this is one of the use cases that I think very interesting. So why we rely on push server? Well, it's their own platforms. They own the platforms. These push servers, FCM, Firebase Cloud Messaging, is owned by Google. It handles Android, it handles Google Chrome. For Apple, they handle Apple devices. For WNS, they handle Microsoft products, Microsoft Edge, Windows operating system. And as for Mozilla Push Service, it handles Mozilla Firefox. So to recap, now we have silent push specifically for Chrome extension, not for any website out there, specific for Chrome extension. But we might not know in the future, maybe this decision will change, because for now, you cannot send silent push in your normal web application, because you always need to set user visible only to true for push to work. In the future, we might not know. Maybe they will allow it.